from a figure given below, what is the order of 1 and 2 and 3? So the figure is given as water content and gamma D graph is shown, and the 1, 2, 3 is given. So at higher moisture content or higher water content, the dry density is going to be very low for the soils which are having higher fine values. So higher fine values means high plastic clay or clay, the finer particles that are increasing in this order. So what we can observe from this figure is it is having higher fine values, less than these fine values, less than these fine values. So from these following options we can say one is not going to be clay, silt and sand. This is not going to be the order because it is in this order. In this option also it is not going to be the order. And if you see option C, sand, silt and high plastic clay. So the finer particles or finer material that are going to be in this sort of clay is going to be in this order, lesser fine values, lesser finer values. So sand is going to have maximum dry density at less water content because of the less finer content. So option C is correct. As it is a direct question, in case of critical slope profile, which of the following is correct? This is the question. So in case of critical slope profile, if you see the options, C2 profile is convex in nature. No, it is concave in nature. C3 profile is supercritical in nature. C3 profile is supercritical. Yes, this is correct. C1 profile is supercritical in nature. No, it is not supercritical. So this is not correct. In case of critical slope, the normal depth is not equal to the critical depth of flow. This is also not correct. So option B is correct. From the following figure, what is the bending moment at B for a cantilever carrying a UDL of W and having a length of L? The bending moment at the other end is going to be WL power 4 by 8EA. So option D is correct. Linear elastic structure delta 1 2 represents. So the displacement at 1 due to unit load at 2. So option C is correct in this case. If it is delta 2 1, the unit load at 2 causing a displacement at 2. So the displacement at 2 because of unit load at 1. This is the way of representation. So option C is correct. Is a 225 mm diameter RCC receiver is to be designed for a self-clearing velocity. To discharge this amount, find the gradient to be provided if the Manning's coefficient is given as 0.013. So we know Q is equal to AB. Q is 0.06, that is equal to pi by 4 d square 0.225 whole square into V. That implies V is equal to 1.51 meters per second. So we know the relationship between the velocity and with the respect of Manning's coefficient and the gradient. V is equal to 1 by n r to the power of 2/3 s to the power of half, where s is the gradient. So we have to provide the gradient. From this, s to the power of half is equal to 1.51 into n is 0.013 divided by r is equal to a by p, wetted perimeter area. So area is equal to pi by 4 d square, perimeter is for circle is pi d, that is equal to d by 4. Therefore r is equal to d by 4, 0.225 divided by 4 whole to the power of 2/3. Therefore s is not, or s is equal to 1 by 56. Option A is correct. Find the modulus of resilience of a structural steel having modulus of elasticity is given and the elastic limit, the value is given as 30,000 pounds per square inch. So modulus of resilience is equal to s square by 2e, that is equal to 3 into 10 to the power of 4 whole square by 2 into 29 into 6, that is equal to 15.5 pounds per inch square. We have to convert the options are in terms of kg per square centimeters. We have to convert this pounds per inch square, then we will get it as 1.1 kg per centimeter square. The option very relevant to this solution is option D. So option D is correct. Find the modulus of volume elasticity. We have to find out for a steel for which the modulus of elasticity is given and the Poisson's ratio we know. So we know the relationship for the modulus of volume elasticity is equal to E by 3 into 1 minus 2 mu, that is equal to 29 into 10 to the power of 10 to the power of 6, sorry, it is 10 to the power of 6 divided by 3 into 1 minus 2 into 0.27, that is equal to 21 into 10 to the power of 6 pounds per inch square, that is equal to 1.4 into 10 to the power of 6 kg per centimeter square. So option B is correct. Here the question is, a 5 cm solid shaft is twisted by means of pipe wrench. The force applied is 200 pounds, applied at 90 centimeters from the axis of the shaft. So find out the maximum shear and stress. We have to find out the maximum shear and stress. S is equal to torque into radius by polar moment of inertia. So all the options are in terms of pounds and inches. We have to convert these centimeters into inches. 5 centimeters means 2 inches, that is equal to, we will calculate the pi d cube. D means 2 inches, that is 5 centimeters. We are converting into inches by 16 torque. What is the torque? 200 pounds. Force into actual distance, 90 centimeters has to be converted into inches, that is 36 inches. Radius is 2 by 2, that is 1. Therefore the value comes to 4585 pounds per inch square. Therefore option D is correct. Minimum thickness of two plates to be jointed is 12 mm. So we know the minimum thickness of the two plates is coming to 12 mm. What is the nominal diameter of the rivet to be used for joining the structural elements? What is the nominal diameter of the rivet that we have to use? So by using Unwin's formula, the nominal size or nominal diameter of the rivet is equal to 6.01 root t. The minimum thickness 6.01 root t is given as 12 mm, that is equal to 20.82, that implies 20 mm rivet has to be provided. So option C is correct. Here the question is a general question. The maximum slender ratio of compression members carrying compressive loads resulting from dead loads and imposed loads has to be 180. From the code we can say it. So option B is correct. If the design speed of the vehicle is given as 80 kmph, find out the value of centrifugal acceleration as per IRC. Centrifugal acceleration is equal to, as per IRC, 80 by 75 plus V meters per cubic second. That is equal to, where V is in velocity in kmph, it is equal to 80 by 75 plus 80, that implies 0.51 centrifugal acceleration. So option A is correct. The process of putting the plane table into the same fixed direction so that the line representing a certain direction on the plane is parallel to the direction on the ground. This process of fixing the plane table is called orientation. So option D is correct.